In the last video, we have looked at what exponents are, and in this video, we are going to look at logarithms. So, when an expression is given in this form, b, the base power a, equals to a number n. So this form is known as the index exponent or index form. So this can be, let us look at an example. For example, 3 power 4 equals 81. So in this case, this is the base, this is the exponent, and this is the number. So, and it's true because 3 power 4 is 81. So this index form can be written in another form known as logarithmic form. Logarithmic form. So the base can be written as log to base b n equals a. So to better understand this, let us check this. Let us convert this index form to a logarithmic form. So we write the log sign, log base. The base is the base as we have seen here. Then write 3, small 3 as the base. Then the number on the opposite side of the equation, that's 81 equals the power or the exponent, that's 4. So that's how you convert index form to logarithmic form. So one way to remember this is looking at it like this. We have two sides of the equation, the left hand side and the right hand side. So at the left hand side you have the sign of the log, then the base and the number on the left hand side, and on the right hand side you have the number, the power, the exponent. So to remember this, you just take the number in between the log sign and the base, which is in between the log sign and the number, and you write it like this. So it's a small number physically here. As you can see, it's a small number. We make it a bigger number. Then let's put to a power of the number on the opposite side and on the right side of the equation. This is a. So we write b, the number between, the number in the middle, power, the number at the opposite side of the equation, equals to the n, the last number before the equal sign. So that's a way to remember this. So here's an example. It says convert this log to base 5, 25 equals to index form. So using this expression, we know that we will first write the number in between the log and the number on the right hand side, the middle number of the left hand side of the equation, which is 5 in this case. Let's raise it to a power of the number on the opposite side of the equation, which is 2. Then equals the number that's nearest to the equal sign, which is 25. So that's how we convert logarithmic form to index form. And it makes sense because 5 squared is indeed 25. So here's a tree. Here's another example. It says convert this index form back to logarithmic form. So first of all write the log sign, then the base, which is 3, small like this, then the number on the opposite side, which is 9, equals to the power or index, which is 2. So that's how we convert index form to logarithmic form. So you need to note that whenever a log is given without a base, as in this case, log n equals a without the base, ignoring the base, without the base, so the base is considered to be a 10. So automatically, whenever a log sign is given in this form without a base, the log, you just consider the base to be 10. That's how it's to be. So then 10 power number of the opposite side of the equation, which is a, equals to the number nearest to the equal sign, which is n. So that's it. Let's look at some examples. Example 1 says log to base 216 equals x. So first we convert this back to the index form. it will be 2 power x equals 16. 2, the number in between in the middle, power the number on the opposite side of equation, in this case x, equals the number nearest to the equal sign is 16. So we know 16 is basically 2 times 2 times 2 times 2, 4 times, which is 2 power 4. So 16 is 2 power 4. We can substitute here. We write 2 power x equals 2 power 4. So the bases are equal by just equating the exponent. X equals 4. X equals 4 because the bases are the same. So in this example, number 1, log to base 2 of 16 equals x. So x is 4. We can write it as log to base 2 of 16 equals x. What's x? X is 4. So that's the solution to that. So looking at number 2, it says log to base x of 64 equals 3. So by writing it back to the index form, we will get the number in the middle, x, power the number on the opposite side of equation, 3, equals the number nearest to the equal sign is 64. So x power 3 equals 64. We are looking for x, not x power 3. So you can find x by just taking the cube root to both sides. So we write x power 3, then cube root, take the cube root, equals cube root of 64. So cube root cancels cube, and we are left with only x equals cube root of 64, that's 4, using a calculator. So x is 4 in this case. We can write it from this, as the base is unknown. Now we know the base is nothing but 4. Log to base 4, 64 equals 3. So that's the answer. So moving on to the next example, we have log to base 7 of x equals 3. By converting this to the index form, we get 7 power 3 equals x. So using a calculator, 7 power 3 is nothing but 343 equals x. So x is nothing but 343. So you can write this knowing this number here, x to be 243, as log to base 7 243 equals 3. So that's the solution to that. And the final example says log to base, it doesn't give a base, log 3x plus 4 equals 2. So remember that whenever the base is not given, we just consider the base to be 10. So this is log to base 10, 3x plus 4 equals 2. So by writing it back to its index form, we'll get 10 power 2. 10 power 2 equals 3x plus 4. 10 power 2 is just 10 times 10, which is 100. Is equals to 3x plus 4. So by subtracting 4 on both sides, this 4 cancels. Positive 4, negative 4, they cancels. 100 minus 4, that's 96 equals 3x. So by dividing both sides by 3, we get x to be equals to 96 over 3. That's 32. So x is 32 in this example.